Assalamu alaikum friends, welcome back to my channel Learn with Fun by Zarar sir. We are continuing with a course of PLC and nanoelectronics, and today's session will be based on CMOS. Hope you have liked all my previous videos and subscribed my channel. So let's begin with CMOS and let's kill it. How does CMOS is better than NMOS and PMOS? Hope you have seen the previous video of simulation of NMOS and PMOS. So we'll continue with CMOS. Before continuing with CMOS, I want you to give a immediate or quick revision of NMOS and PMOS that we have already discussed in the previous lecture. So this is my NMOS which we have already discussed. This is its top view. This is my PMOS and this is its top view. Channel length and width and activation is already been known. But to start with CMOS, I want you to be aware about that NMOS is activated when it gets 1 and PMOS get activated when it gets 0 for digital world. So this is very important for today's discussion. So I want you to be aware about NMOS and PMOS this part. So can we continue to the next part of this video? So how does CMOS works? For CMOS working, this is the diagram for CMOS. It contains or it has one PMOS over here, and this is one PMOS and this is NMOS. So how does it work? It's worked in a fantastic manner, and you know how it works. The answer is when we'll complete one understanding, we'll be able to answer. So look at this diagram. This is CMOS, which contains PMOS logic and NMOS logic clubbed together. So if I give one logic for digital, as we have started with digital session, after completion of digital part, we'll move towards analog world. So if I give logic 1 and you are aware about for logic 1, NMOS will get activated and PMOS will not be get activated. So if NMOS get activated and PMOS is not activated, then we can't be able to draw any current from supply VDD. So if we can't take or drain any current from supply, that means output will be 0 since your PMOS is not working. So if I give the logic 1, I am getting output as logic 0, and you know what is this? This is nothing but an inverter, right? So let's take another example similar. If I give 0, logic 0 as input, now you are completely aware for logic 0, PMOS will get activated and NMOS will not get activated. So if PMOS is activated, which means that current will be drawn from the supply but will not reach to ground since my NMOS gate is not activated. If this is not activated, no current will flow from drain to source. That means this all current will goes to the output side and will get output as 1. So it's a fantastic way that you can understand my CMOS as working as an inverter. So CMOS works as an inverter. It's a fantastic part, but you should know that it contains of PMOS and NMOS. And the important point, while we'll discuss analog world, do remember this small point, and I'll make sure I'll repeat this over there also. This part is known as load section, while the down part is known as driver section. The upper part is load part and the down part is driver part. Okay, let's move further and understand something better. So let's start with fabrication of CMOS. In CMOS fabrication, this is the first way in which we can fabricate CMOS, which include a P substrate and N diffusion. So if the P substrate is there, that means the given MOSFET is NMOS. And inside NMOS, we have something called as N diffusion and now here P diffusion. So if the diffusion is P types, that means this is PMOS. So inside NMOS we have PMOS. This means this is P well process. Okay, this is my P well process. So this is the one way of fabricating CMOS. The another way of fabricating CMOS is this way, which means we have N substrate. So if we have N substrate, this means this is my PMOS, since this is P diffusion over here, and we have N diffusion 2, that means this is my NMOS. So inside PMOS we are fabricating NMOS. That means we are creating a well over here. So this is known as N-well process. So this is my N-well process. So one we have P-well process and another we have N-well process. Now usually people prefer from this two. But if you have to avoid the problems such as CMOS latch-up, the theoretical aspect and you need to discuss this, then the third fabrication layout takes place, and which is very important to understand. See, you have a lightly doped piece of sheet. Inside this you fabricate both. That means you create both well, N-well as well as P-well. So this diagram, which include N-well as well as P-well, is known as, can you guess? It is known as twin tub process. So this is twin tub process, and people prefer twin tub process from P-well or N-well. In our practical point, we'll be using one well out of it. We won't be using twin tub. But usually the people prefer, while fabrication, they prefer either N-well or prefer P-well. But if the design is very important, they prefer twin tub process. So can we move further in the CMOS fabrication layout? And the last topic is stick diagram, which is very important while designing CMOS. So the last part is stick diagram. Now how to make stick diagram? There are two ways to make stick diagram, or there are two approaches. One way to make stick diagram is normal approach or standard approach, and the other way is, the other is important, Euler's approach. It is mentioned in the book author name as Neil Weste, which I have already mentioned. So let's look at stick diagram for the fabrication. So if the diagram which is on the left hand side you are aware about, it is nothing your PMOS and NMOS combination, which is your very important CMOS. Now see the supply, VDD and VSS, which is mentioned over here, VDD and VSS, the supply are usually made from blue lines. So this blue lines indicate it as supply lines. And now we move towards PMOS and NMOS. And we have already discussed that my PMOS will be denoted by yellow color and NMOS will be denoted by green color, and the gate on PMOS and NMOS will be denoted by red color. So see, this is my yellow color for PMOS and green color for NMOS, and the gate cutting both is your red color cutting both PMOS and NMOS is your gate. Now if I join this two, see, this becomes my input and this is my output. So this is the final stick diagram for your CMOS. Now the important point or to take away from this is, many research papers and books are published on CMOS. So what are the advantages of CMOS? Why it is preferred over PMOS and NMOS? They both act as a switch. This is also acting as a switch. No doubt it is acting as an inverter over here, but it is acting as a switch too because it's a combination of PMOS and NMOS. So why people always prefer CMOS? I will be discussing this in this practical point. So the next video of practical is very important to understand why CMOS is better than PMOS and NMOS. Thank you. Hope so you have understand today's concept. Now, if I got time, I'll be teaching you how to make stick diagrams using Euler approach too. That's it from my side for today's lecture. Hope you have enjoyed the lecture. Please like the video and comment below if you understand something out of it. Okay, thank you, and do subscribe my channel, share with your friends who are in need to understand VLSI and nanoelectronics course. Anything else you can comment me. Thank you everyone. Stay home, stay safe and pray for each other. Thank you guys.